Okay, the first question in the exam, let me talk about the problems in assignment 1. Okay, uh, you have 5 students and you have xy pairs, xi and yi. Okay, and the question is what linear regression equation best predicts statistics performance based on math aptitude score? And if the student made an 80 on the aptitude test, what grade would expect her to make in statistics? And how well does the regression equation fit the data? So I just give you the solution. But in this video, I would like to explain these questions again. Okay, because you're going to see very similar problems, okay, in the midterm examination. So you have 5 students, all right. The first thing that you are going to find is slope and y-intercept. Okay, if you can get these two values, slope and y-intercept, you can get the linear regression equations. So we have the formula to compute slope and also y-intercept. So in order to compute slope, okay, you need to create a table. Okay, you need to create 3 more columns, x squared, y squared, and x times y, because you need a summation of x squared, summation of y squared, and summation of x times y. Okay, and then when you get sum of x squared, y squared, and x times y, okay, you should substitute into the slope formula, okay, to compute slope. So easy, okay, you can just compute x squared, y squared, and x times y, and then this is the summation of x squared, summation of y squared, and summation of x times y. Okay, and then you get the slope, right? Replace the values here, substitute the values into the formula. So this time you get slope 0.64. And for y-intercept, you need to compute x bar and y bar. Okay, x bar, average of x, average of y, and then the formula y-intercept is equal to y bar minus beta 1 x bar. So you can just substitute all the values into the y-intercept formula. So you get y-intercept 26.78. So now you can get the linear equation. Okay, you can get the predicted line. Okay, in the exam it's very similar. So next question is, if a student made an 80 on the aptitude test, what grade would we expect her to make in statistics? So look at the questions. Okay, we give you the value of x. All right, if x is equal to 80, what is the predicted y? Okay, what is the predicted y? So you have linear equation, so you can just replace x with 80. So the predicted y is 77.98. So this is the predicted y or predicted score. Okay, to answer the second question, how well does the regression fit the data? So you have to compute coefficient of correlation. So we have the formula, all right, r equal to ssxy divided by square root of ssxx times ssyy. So this is a formula to compute ssxx. Okay, ssyy and ssxy, you can just substitute all the values here, okay, into the formula. Okay, and finally you get the coefficient of correlation R. It's around 0.693. Okay. This is the first step, and next you create another table in order to compute sum of square error. Okay, you create the solution table. Okay, x, y, and you have the linear regression equation. You put in here. Okay, and you can compute y, the predicted y. So you compute y minus y with the hat, and then y minus y with the hat over 2. Okay, and finally you can compute sum of square error. Okay, in this solution table you can get the sum of square error. So, and then you can compute variance. Okay, because variance is equal to SSE divided by n minus 2. SSE is 327.85 divided by, okay, 5 minus 2 is 3. So the variance is 109.2. So S standard deviation is the square root of variance. So you can get the value of S equal to 10.454. And now you can compute the coefficient of determination R square. R square is equal to SSYY minus SSE divided by SSYY. Okay, finally you get the final value coefficient of determination R square. Okay, 0.479. Okay, that is all for the computation, and it is enough, okay, for answering the all the three questions, okay, in the first assignment in regression analysis. So you may see the very similar problems in the exam to this, okay, to this problems in assignment 1. Okay, please go and review and try to understand. And the most important thing is you need to interpret the data. Okay, when you get the linear regression equations, okay, and what does this mean? Okay, what is the predicted data? What is the predicted y values? Okay, and then when you get the linear regression equation, how to use it? Okay, how to use it? Okay, you answer the second bullet, right? If a student made an 80 on the aptitude test, what grade would we expect? Okay, we predict. We will predict it. Okay, what grade would we expect her to make in statistics? Okay, you need to know how to use the regression equation. So, and last question, how well does the regression equation fit the data? Okay, it means in order to answer this question, how well the regression equation fit the data, so you need to compute the coefficient of determination, or R square. Okay, you need to compute R square. But in order to compute R square, you need to compute SSE, right? Sum of square error. To compute SSE, you need to know linear regression equation, and you need to compute y minus y with the hat, okay, or predicted y. Okay, the actual y values minus predicted y, and then you can compute sum of square error. Okay, from bottom to up, you can trace back. Okay, to compute SSE, and then you find coefficient of correlation, linear regression,